So, good morning, girls. Today we are going to discuss about linked list variants. So, before going to linked list variants, let's first we will see what a header node is. So, here actually there is a pointer at the starting of the linked list. Already we have discussed about this point in earlier classes. Uh, which is called header pointer. Okay, so what is the use of it? Because if we don't have such a kind of pointer, we cannot access the linked list. I mean, where the linked list starts. So we don't have uh, the starting point of the linked list. So that is the reason always we store the starting point of the list or the starting address of the list in a pointer called header pointer. But there is also a node called which is a dummy node attached at the start position, which is called header node. So there is a difference between header pointer and header node. Header pointer points to the starting position of the list. See, pointing to the first node of the list. Um, this Without this pointer, we can't access the list. It is like an entry into the list. But what is this header node? See here, header node is a special node that is attached at front of the list. And this node may contain special information in data fields. So this header node is something special from the other nodes of the list. How it is special? It is special because it contains some special information of the data fields. I mean, it contains some special information in its data fields. So, what kind of information generally it may contain? See, it may contain about the total number of nodes in your list, okay, and it may also contain some other information. See, here in this header node, it has so many fields. These are the actual nodes of this list, but this is the header node. So you can differentiate it by you can uh, by seeing itself you can identify or you can say that this is your header node. How? Because it has so many fields or some special fields which are like the length, I mean how many nodes are there in this list apart from that node, and which city, which department, and which year. So the header node can contain some special information or extra information in it. So in this example here only 4 is present. What does it mean? On the whole there are 4 nodes in this um, what you say linked list. It's specifying like that there are 4 nodes in this list. So this kind of header node is helpful. This kind of linked list is called header linked list, and it is helpful when you have to count when you're using or when you specify the count in your program, when you want to count the number of fields in your linked list, and then you have to traverse the whole list, like from this one to this to this to this. So finally, till you reach null, you have to traverse. So that is the reason in some where you need in some places where you need to calculate the number of, or the count or length of the list, Then you can use this kind of header list which specifies the total number of nodes in the list. It says that there are 4 more records ahead. So this is your header node, and see, this is how you represent the header node in your program. This is your normal node, which only contains the employee name and link. But this is your header node, which will contain something extra because it has some special information. So it is specifying your city, department, established year, and also the link to the first node of the list. So in this case, header pointer points to the header node of the list, and the header node contains the link of the first node of the list. So when there is no header node in the list, the header pointer will be pointing to the first node of the list. But when there is a header node in the list, the header pointer will be pointing to the header node of the list, and the header link field of the header node will be pointing to the first node of your list. So this is about your header pointer and header node, the difference between both of them. Next, types of linked list. Depending on the link fields, number of link fields in your linked list, you can categorize the linked list into two types. You can classify them into two types: singly linked list and doubly linked list. So generally what a linked list will contain, linked nodes, what a node will contain. Node will contain data field. Along with the data field, it will have a link field. If it has only one link field, okay, then it is called singly linked list. I mean, it is going to point only the successor in the sense the link which comes after this. This is its successor. This is its successor. This is its successor. So, singly linked list will point to only the successor. It will have only one link field. So, that is the reason it is called singly linked list. So, what is that? You can say it as the advantage or disadvantage. The disadvantage of the single linked list is it can traverse only in one direction. It can traverse only in one direction. Yes, because it can't go back from this node to back, from this node to back, because this node contains only the next successor node in the list. So there is no way to go the ith node from the I plus 1 node. So if you are, this is your I plus 1, you can't go back to the I node because there is no address of the last node. I mean previous node, predecessor. So this is the disadvantage of singly linked list. Next, doubly linked list. Just opposite of it. So what is doubly linked list? See, doubly linked list will have two link fields to store information about the one to the next and also about the one ahead of the node. Ahead in the sense, say if this is your node, so this will contain the address of the successor, and this link will contain the address of the predecessor. So this is next and this is ahead. So this is what your doubly linked list is. So in DLL, from every node, the list can be traversed in both the directions. So the limitation of singly linked list was it can traverse only in one direction. In doubly linked list, it can traverse in both the directions because it has the address of both the nodes, I mean successor as well as predecessor. So in both SLL and DLL may or may not contain the header node. Header node is not compulsory for all the lists. It may contain or may not contain. If there is no header node, there will be the header pointers to indicate the starting position of your list. The one with the header node is explicitly mentioned as header single linked list or header double linked list. Okay. Next, linear and circular linked list. So what is linear linked list? So all the linked list till what we have seen in till now, single linked list or double linked list, whatever they are, all they are linear. Linear in the sense they are traversing in a linear fashion, straight line fashion. So they are called linear linked list. And why they got the name linear linked list? Because all elements of such a linked list can be accessed by traversing a list from the first node of the list. See, uh, so all the elements or any element of the list can be accessed by traversing starting from the first position. You can't traverse somewhere else, or you can't start from the middle of the node and go to any particular node which you want to access. So all elements of such a linked list can be accessed by traversing a list from the first node of this. If you want to go to this node, so you have to traverse to the head, first node, second node, and finally you can reach the third node. What is this circular linked list? See, circular linked list is nothing but the link field of the last node is set in null in a linear list to mark the end of the list. Okay. This link field of the last node can be set to point to the first node rather than. So instead, the last node which you are, which indicates with the last node of the list in which the link field is set as null so that it indicates the end of the list. If you replace that null with the link of the first node, with the address of your first node, then it is called circular linked list. You are forming a square. You are forming a square like this. So in such case, what you call that list as circular linked list. So what is the use of this? So in such case, if you want to move on to this second node from the fourth, generally what happens? If this is a linear linked list, it will have null and it will be indicated by the rounded symbol. But now, if this is a circular list, if you want to move on to this node from this node, you have to just use the link and you'll go to the first node, and no need to refer to the head pointer again. You'll directly go to the first node, and from there you can go to the second node. So it is possible to reach any other node in the list. No need to start again from the header or head pointer to, or starting of the go to the starting of the list. You can directly, if you reach the end of the node, it will get pointed to the first node of the list, and you can reach any other node in the list. And also single circular list could be again singly circular or doubly circular, with the header or without header. So again there are variations in this circular list, single circular list, which is having only one link field, double circular list, which is having both the fields, predecessor and successor address fields, and with the header node. And say this circular list is without header node, singly circular list without header node, and you can have with header node, without header node. Okay, so this is what your circular list is. So next, non-circular list or grounded list are nothing but your linear list or single list, in which the last node is always set to null. So it is pictorially denoted by the ground symbol, which is used in your electronic circuits, which indicates that it is going to be the end. It is the end of the list. So tomorrow we'll see in detail about doubly linked list and how to insert, delete, create, or create a doubly linked list, how to insert nodes into it, how to delete, how to traverse, all these. If you have any doubts, ping me in the group.